So if you're listening to these slides in order for this chapter, you heard, and this is actually, I believe, the same photo we had before. I talked about the celestial object called the Milky Way, and I really think it came from like looking like spilt milk across the sky, a band. And like I said, that milky appearance actually are little faraway stars. And we are looking into the plane or the frisbee part of our galaxy. Isn't it just gorgeous? On my list of things to do is to be able to photograph things, beautiful celestial objects. So this is kind of a what we call a face-on view of what our galaxy we think looks like. You can kind of see it looks like a hurricane, right? Kind of how a hurricane has spiral arms, and so also spiral galaxies have kind of dense regions where you see extra stars and extra gas that make up the arms. And so this is where, and we'll be talking more about the Milky Way. Oops, I was trying to get the Milky Way. But we are kind of located, like I think I said before, about halfway between the center and the edge is our star. And remember, it takes it, and I think we saw it kind of going more like clockwise, but 260,000, I want to say, years to complete one orbit about. BH stands for what? Black hole in the center of our galaxy. So what these blue arrows are showing you right here are saying that as the Earth, let's see if I can kind of make this a little bigger to make my point. Okay, so that yellow dot there is the sun. Okay, and then you have to picture all of the planets orbiting counterclockwise about the sun. So we see different parts of the Milky Way. So for instance, if we are right here, I'm going to make us big. We're really not that big. Our daytime, let me just go with our nighttime. Our nighttime skies, we are going to see this part of the Milky Way galaxy. If we are over here in orbit about the sun, our nighttime skies are going to see this part. Okay, so honestly, different times of the year, we see different parts of the Milky Way galaxy. It's kind of fun. So just kind of finishing up on something I already talked about, this idea that, remember we started out with these star trails, that if you were to open up the shutter of your camera, that actually you could capture that, that star sweeping across the sky and making a bullseye sort of appearance around the star Polaris. So down here, I think this is quite clever. What your author has done with these two pictures is this one is how the stars appear to move in the northern hemisphere. Okay, this is the northern hemisphere. So in the northern hemisphere, we would look north to see our pole star. And of course, Polaris is the name of a star. Okay, it's in the constellation Ursa Minor, Little Bear, and it's actually Polaris. It's kind of fun. It's part of the asterism, the Little Dipper. So what's being shown here is, let me kind of zoom in a little bit more. You're being shown 6 hours afterwards. Let's see, how do I say this? Well, it says we can start here. So for instance, the Little Dipper, this is hour 1, hour 2, hour 3. Well, it says 6 hours. So how do I want to say that? Every 2 hours. So 0 hours. This is 2 hours later, 4 hours later, 6 hours later. Okay, we got that? Okay, 0, 2, 4, 6. And everything else moves, dun dun dun, counterclockwise, including the Big Dipper. So what does that mean? It means here we have 0 hour, this is 2 hours, 4 hours, and 6 hours for that Big Dipper. Isn't that cool? So the Big Dipper, all the stars sweep counterclockwise. I think that's neat. Well, you say, what if you are in the southern hemisphere? Well, if you're in the southern hemisphere, the best you can do, you can't, if you're south of the equator, as hard as you try, depending upon if you're, 5, 10 degrees south of the equator, you're not going to be able to see the North Pole, but you'll begin seeing the South Pole. And there is no pole star. Okay, there is no star here. So the best we can do is, and that's okay, they're fine with that. Okay, don't make it sad. Um, the best we can do actually is to use a constellation called the Southern Cross. Now, notice that, and we'll try to explain why this is, but if you are in the southern hemisphere and you're looking at the motion of stars, you are going to look, there's no pole star here. Okay, there's no pole star here, so you just have to look in that region. And motion is going to be clockwise, okay, as you look at motion. So, for instance, and what they do is they use the Southern Cross, about 4 lengths of the Southern Cross, to get to where the region of space is that motion occurs around. So this is 0 hour, 2nd hour, 4th hour, 6th hour, okay? So the motion again is clockwise. So I hope that works, how it works for you. One other important awesome thing, okay, regardless of which hemisphere you're in, if you look for either the pole star Polaris or the region of space around which rotation occurs in the southern hemisphere, the angle that the star Polaris makes, or the angle that that region makes above your horizon, is directly related to where you're at on the Earth with regard to latitude. I'm going to try to, I know this picture already looks kind of messy, but let me try to kind of show you what I mean. We're going to be talking about how do you kind of gauge objects in the nighttime sky. And one of them is with angles above the horizon. So for instance, if this line is supposed to represent the horizon, oh, let me erase that. Okay, one single line. This line represents the horizon, okay, and this line goes up to the star Polaris. That angle right there, okay, whatever that angle is your latitude. So for instance, around here, that would be about 41 degrees. Okay. Similarly, over here, this person is wearing shorts, Australia maybe, would look at this angle right here for his latitude south of the equator, his or her latitude south of the equator. So here's the deal. If you've ever heard of a, gosh, what do they call that? When you're, what they used to use when they were sailing, a navigation device. The navigation device would actually look at stars, the pole star, to get a sense for what latitude they were at.